Hello students. So in this lecture we will be starting the network theorems previous year 15 plus previous year gate questions of electronics and communication. So this whole lecture will have many sub parts and we will be solving previous year gate questions from two 2019 to approximately 2000 and another important questions that are from 1998 or previous gate questions. I will be adding them in the video lecture itself. So by this video lecture you will be completing your network theorem previous year questions. Okay, and this is provided by you by EDAMIGO team, a team of gate and engineering services toppers. And from the toppers I do not mean like top 100 rankers, I mean that top 10 rankers of gate and engineering services. So this is the best material available in the market. Now let's start with question number 1 of this part. This was asked in GATE 2019 Electronics and Communication paper. Now it's a very simple question because we know that the T network are always reciprocal. So T networks are always reciprocal. Sorry. So as we know that T networks are always reciprocal. And what is the meaning of reciprocal? So the reciprocal means, let me define reciprocity. So reciprocity. So in simple words, the reciprocal theorem states that a circuit will be reciprocal if the ratio of response divided by input remains same even after changing the location of, or I can say in the better word will be interchanging, not changing, it will be interchanging. Interchanging the location of response and input. Okay, so suppose, and in this question it is given that it's a T network. So and T networks are always reciprocal. Now if we assume that in this circuit figure A, 5 volt is the input and current in this branch is the response. So 5 volt is the input and 1 ampere current that is available at the output is the response. Now I interchange the location. Okay, now in place of the current where I was measuring current, I place the 5 volt battery, and in place of the 5 volt battery now I start measuring the current. So this is what is happening in the figure B. So in place of the location, for example, if I say node A, node B, node C, node D. So in figure A, I was providing voltage in the terminals, between the terminals C and D, and I was measuring current between the terminals A and B. So I am providing voltage between C and D and measuring current between A and B. Now in figure B I just interchange the location. Now between A and B I am providing a battery and measuring the current between C and D. Now since all the T networks are reciprocal, okay, all the T networks are reciprocal, so the ratio of response divided by the input remains the same. So here the input is 5 volt and thus the response will be 1 ampere, that can be easily calculated. Okay, so the answer to this is 1 ampere. Okay, so the answer is 1 ampere. A very simple question. Now this is question number 2 for the this part. Here we have to find the Thevenin equivalent resistance between P and Q. Okay, now first of all I will copy the figure. Now since in the circuit there is a dependent source, that is 3I0, and there is a independent source 10 volt, so to find out RTH we short circuit the independent voltage source. So I will short circuit it, and since the circuit has a dependent voltage source as we can see here, so to find out the Thevenin resistance we will have to follow the method. So I will write this: since there is dependent source, so to find RTH we will apply a battery between PQ terminal. So let the battery is of V0 voltage and calculate I0 current from the battery. Okay, and RTH will be V0 upon I0. Okay, so I will redraw the circuit again. So this is a dependent source. Okay, so 1 ohm, I0 is flowing here. So P and Q, 1 ohm resistance is also there. Now since between the terminal A and B, for example, I take this as A, this is at B, it is short circuited, so 1 ohm resistance is removed and it is short circuited. Okay, now I apply a battery of V0 voltage and assume that the current is capital I0. Okay, now since V0 voltage is also across this 1 ohm resistance, so I can say that I0 is equals to V0 upon 1. Okay, also since 3I0 is the voltage across this resistor, so the current will be flowing in this direction, that is 3I0. Okay, and we know the value of I0 is equals to V0. So now if we assume that this node is grounded, then, and we know this node is at potential V0, so this node will be at potential V0 minus 3I0. Okay, now I will redraw the circuit. I have to add a page here. Okay, so I will redraw the circuit again for simplicity. So this is plus minus, I will write 3 V naught, okay, because I naught is equals to V naught. So the current here is V naught, 1 ohm resistance, V naught is the voltage, capital I naught is the current, okay, and 3 V naught is the current. Voltage at this node is V naught. Voltage at this node will be minus 2 V naught, and there's a resistance, 1 ohm resistance connected like this. Okay. So since this is grounded, we can see that the current will be flowing from ground to node. For example, this is B, this is A. Okay, so the current which will be flowing from ground to B node will be 2 V naught. Now if I apply KCL at node B, since 3 V naught is coming in, 2 V naught is coming in, so the current which is going here will be 5 V naught. Okay, now at node A we can see that the incoming current is I naught. At node A, incoming current is I naught, incoming current is 5 V naught, outgoing current is V naught, and outgoing current is 3 V naught. Okay, so incoming current, outgoing current, and outgoing current. So we can see I naught is equals to minus V naught. So we can say that since I naught is equals to minus V naught, so V naught upon I naught is equals to minus 1 ohms. Okay, so this is your RTH, that is minus 1 ohms. Okay, so we have solved 2 questions in this part. We will be solving more questions in another part, so stay tuned and thank you.